There we go.
Hello, everyone. We are very, very excited to welcome Andrew Dotson to UChicago for a Society of Physics Students talk. Andrew Dotson graduated from Old Dominion University and is now a graduate student at New Mexico State University, where he is studying nuclear and particle physics. But I'm sure most of you know him from his YouTube channel, which has over 128,000 subscribers, where he makes videos on physics skits, vlogs, and just lectures about physics topics in general. But I don't want to take too much of this time up. Let's please give Andrew Dotson a big round of applause and thank him for coming today.
Thank you for the very warm introduction, and thank you, Miles, for inviting me to come speak today, and for you guys sharing some of your time on a Monday evening, where I'm sure you'd rather just go straight home and spend it with me and hear me talk today. But my name is Andrew Dotson. He pretty much summarized my entire talk by saying what it is that I make videos about, but I'm going to try to not be too redundant. So I'm a grad student at New Mexico State University. I'm doing research in theoretical nuclear and particle physics, and what I'm here to talk about today is that I make physics videos on YouTube. Now, when Miles reached out to me, he asked me to give this talk, and I said, well, what should I be talking about? And he said that when you guys have speakers, they give a general discussion of what their research is, things like that. Now, I don't know how many of your speakers are giving their talks remotely, like via webcam, this whole situation, but in my experience, Murphy's Law is particularly unforgiving when it comes to giving presentations not in person. I think it's the fourth law of thermodynamics that says if PowerPoint can fail, it will fail. So needless to say, this is going to be more of a discussion than anything else, not a real presentation. And for the exact same reason, I'm not going to be talking about research too much. I could say I calculate matrix elements of the energy momentum tensor for different interactions in quantum field theory. I get rid of infinities, typically using dimensional regularization. I'm getting bored just saying that. Now, if people are curious about my research towards the end of the talk, I have a 6-foot whiteboard right here. We can go a little crazy if you want. But the primary goal of this talk is going to be to talk about why I started what I think is one of the more niche YouTube channels and why it works. Now, there's actually a good amount of people in this room. I want this to be relatively casual. I don't want it to just be me monologuing for an hour. I don't know if you've tried to talk about yourself for an hour. It's really hard. I've been trying to write down what to talk about for a week, and let's just say I got about 30 minutes in, because I'm going to need some discussion, some questions, some comments. So don't feel like you're interrupting me or anything like that. If you have a comment that you'd like to make or a question that you'd like to ask, just say so. I'll try to hear you. I don't know. Can someone say something? Can I hear you guys?
Hey,
hello.
Okay. So you're gonna have to project a little bit if you guys have questions or whatnot, or maybe relay it to the front. Whatever makes the most sense for you guys or you all. I guess let's start off by reading the room. This is going to be a little bit of a back and forth. So how many of you, I know that this is for SPS, how many of you are undergrads? Can you raise your hand? Everybody, okay. Any grad students? No? Any professors? Okay, so this is a one-dimensional problem, okay? That's something. So, how many of you, just to maybe expand this on a different basis, how many of you have your own maybe YouTube channel, or I don't know, or thinking about making your own YouTube videos? Okay, it's not that I don't believe you. That is what it is. I don't believe you. I think there's more of you in there, and I hope throughout the rest of this talk you'll feel more comfortable sharing the fact that you'd like to put some stuff on YouTube and share some of your perspectives. I did see one hand. Who was that raised their hand?
Miles.
Oh, Miles?
Yeah.
Oh, okay. All right. I'm going to be picking on you tonight then, probably. But yeah, that's going to be the moral of this. I'm going to be talking about YouTube, and I want you guys to feel free to ask questions and stuff. I don't know how this stuff usually goes, but I think everyone will be much less bored if they're allowed to have a little bit of a say in the conversation. Okay, so that was one hell of a long introduction. Let's go ahead and get started with what I do. So, at the end of the day, I'm interested in science communication, and when it comes to science communication, there is an abundance of the popularizers, right? Like, what are some things that people that you see talking about physics on TV, what do they talk about? What do they talk about? Some topics. No need to raise your hand. Say that again?
Quantum mechanics.
Quantum mechanics, certainly in every Facebook article I've ever seen ever that talks about helium crystals. Good point. What else?
Climate change.
There's quantum mechanics.
Physics?
What's up?
Dark
Say
matter.
that again? For sure. Yeah, the things that I always saw, at least on TV, like they talk about wormholes, time travel. Every show ever has to talk about string theory at some point. I think that's like a rite of passage. And on Facebook, everything starts with quantum physics, or it says physics shows that you can go backwards in time if you rub this crystal on your body, whatever. You guys are learning in your classes, right? I think it's fair to say that we're not all spending our times talking about string theory in, classical mechanics or something like that. I mean, maybe we all just collectively missed the Bill Nye episode on Clutch-Gordon coefficients, but I don't think that that's the case. The goal of this talk is not to convince you that these popular science topics need to make their way into the physics classroom, but rather to point out that it's a bit misleading. I mean, it does what it's supposed to do. Those popular science shows and channels and articles do what they're kind of supposed to do, where they reel in prospective physics students. They get them interested. It definitely worked on me, but it's a bit misleading. I mean, came the second lecture of my physics class, and I was like, okay, joke's over, start talking about string theory. But that didn't happen. So, what I think is more important than trying to put this stuff into the physics classroom is that there needs to be more exposition saying what you can actually expect should you choose to do a degree in physics. What is it actually like? What are the courses you're going to be taking? And maybe share some of the experiences. What is it going to be like in those courses? So throughout the rest of this talk, I'm going to be discussing why I started my YouTube channel and kind of the direction it's taken, over the past few years. Are there any questions so far? I'm going to be sipping on water. I'm getting a little bit sick, so I need to nurse the sore throat. So please ask questions and stuff. Let's drink water or something. Did I see a hand in the back? What is that? That's not a person? Okay, sounds good. So, before I get into the whole YouTube thing, I guess I'll give a bit of an origin story, why I started doing physics in the first place. So, I didn't start... Wait, someone say something? No. I thought I heard something. Huh?
No.
Okay, I assume that means no. Continue. But I didn't start out as a physics major. I actually started out in biology. I wanted to be a medical doctor. And in a healthy way, I was very fascinated with cancer. I always thought that it was interesting and just, I've always been very good with kids, and I'm good at compartmentalizing good things and bad things, so I thought my personality mixed with my interests would lead to pediatric oncology. I thought at the time that was my calling, like most 18-year-old boys. And for that reason, I really, really wanted to like biology. I did. I gave it an honest shot. In my experience, and I'm sure it depends on the person, and I'm sure it depends on how far you go into the field, it just seemed like a lot of, this is what this is called, and this is what this is called, ad infinitum. There was a bunch of definitions and vocab and jargon. And there's this video of Richard Feynman where he's telling a story, and he talks about how when he was a child, he would go outside and play with his friends, and his friends would give him kind of a hard time for not knowing the names of different birds when they were out playing. He said, "Your father doesn't teach you anything." His story, I'm sorry for the bit of the sexist undertones, but that's how the story goes. He said, "Your father doesn't teach you anything." But the thing is his father would teach him about birds. They'd go on these long walks and they'd say, "This is the name of this bird," and even go over the names of the bird in different languages. And his father said that once you know the names of the different birds in all the different languages, you still know nothing, absolutely nothing about birds. And it's when he learned that knowing the name of something doesn't constitute understanding it. And how I felt taking these biology courses, I finally learned how to put it into words. And that's been a recurring thing. It's when I feel something like how Feynman say it. It's typically the better way to say it than how I would have. That's what planted the seed, was pointing out why I didn't really like biology too much. And then, I'm going to take another sip of water, I'm sorry. But I visited home one time after this, and I had a conversation with my dad, and he was asking about how school was going, like what was I learning about in school. And instead of talking about how interesting the brain is, or the cell cycle, or things that I was supposed to be interested in, I would start talking about what I saw on Into the Universe with Stephen Hawking, or what I saw on Cosmos. And he pointed out that when I come home, I'm never talking about biology. I'm always talking about these crazy things that I'm seeing on TV, these things that reel me into physics. And he suggested that maybe that's what I should be studying instead. Maybe my heart isn't in biology. The reason I wanted to be a doctor was just because I'd always wanted to be a doctor, and I didn't really put much more thought into it than that. It was like, okay, I guess that's what I'll do. So I ended up taking my dad's advice after thinking about it a lot more. I moved back home and I switched major to physics. I started going to a local four-year university that was much cheaper than where I was going, because it had like I don't know what they call it. The school that I went to initially, it had two big things that it was known for. Art school, that wasn't for me, and a pre-med program. So if I wasn't going to do medicine, it didn't make sense to go there anymore. Go home and save some money. So in essence, that concludes kind of Act 1 of this presentation, which is what got me into physics. But what I've always found particularly, I love telling that story. It's one of my favorite stories, is sharing how I got into physics. But I also really enjoy hearing other people's stories. What planted the seed for you guys? So I kind of learned to flip the role a little bit and see, are there stories that you guys, like what got you into physics? Are there any stories that you would like to share? Don't be shy. If you're shy, I'm gonna pick on Miles. Okay, well, Miles.
You gotta start the conversation. I don't know, for me, it was sort of like the work that people like you were doing, like watching Vsauce or Minute Physics and ASAP Science, and just really learning about like sort of the outer ends of physics without being able to dig into it. And I don't know, I just wanted to learn more and explore it more, and that's ultimately why I chose to study physics right now.
Awesome. Yeah, I think that's something that we can all kind of see in ourselves a little bit, as you're introduced to this bubble that's on the surface, and you want to get a little bit more in depth to that. I saw another hand.
Yeah, there was a poster at my high school that said, if you study engineering, you can do engineering. If you study physics, you can do engineering. Because it's more, broadly applicable to lots of problems in the world currently.
Okay, yeah, so it makes you more well-rounded. I've heard a similar joke that kind of flips the script to the physics student, where it says, being a physics student, you become pretty good at math, but not as good as a mathematician. You get pretty good at building things, but not as good as an engineer. You get pretty good at coding, but not as good as a suits computer science major. So it's like you become this jack of all trades, but master of none. So there's always someone who actually does it who's still better than you. But any other hands? Any other stories? Yes.
Okay. Well, it's kind of embarrassing because for me it was the movie Interstellar.
Yeah.
And after this, I really like math, but honestly, there isn't much of way I can impact the world by math. And so I thought that the closest thing to math is probably physics. Yeah.
Listen to you, maybe?
What?
You guys cut out for a second. I heard something about not impacting the world with math, and then it went blank.
Well, physics is basically the closest thing to math that I could find that is not math.
Where you can apply it or something like that. I think I see what you're saying. Yeah, Interstellar was a big thing for me as well. That's what more or less piqued my interest in general relativity, because at my university, there was no course in GR that was offered. It's probably for good reason. I mean, I don't know how much exposure to it you all have. I mean, when I looked through your research specialties, it seems like you guys have a lot of emphasis on astronomy and astrophysics. So I don't know, maybe you guys come out of the gates learning, about Christoffel symbols and stuff, but that wasn't the case for me. But Interstellar was the thing, was like, okay, let me look into this more. What the hell is an affine connection? But yeah, that was kind of the catalyst to learn a specific branch of physics for me. Interstellar movie's gonna be pretty powerful. Okay? Maybe one more, or? No? Going once? Okay. So that kind of summed up Act 1, talking about what got me into physics. And now we're going to do Act 2, which is Operation why I making YouTube videos. It's a working title. So I said that I moved home, I switched to physics. That was a really big decision to make. And I wanted to know what to expect. Now, Miles brought up looking up all these videos on YouTube, mentioned Vsauce and things like that. That's exactly where I went when I wanted to know what to expect. Not to Vsauce, he's not a physicist, but to YouTube. And I came across a YouTuber named Simon Clark. And some of you may be, if you know me, you definitely should know Simon Clark. He made these videos at the time on what it was like to be an Oxford physics student. And since then, he's graduated, he's got his PhD, and he's moved on to making other kinds of educational videos. But he started out making these vlogs showing kind of day in the life of a physics student at Oxford, but nonetheless, it was physics. And
Andrew,
it was...
you're frozen. Do you mind just turning your camera on and off? Sorry about that.
Oh, I'm frozen?
Yeah.
That's awkward. Let me just do one of these then. Let me know if you can see me again, if and when. Oh, I see that I'm frozen too.
Should we just try to call you back?
Works for me.
All right. Just 1 second.
Sure.
Slight technical difficulty. Sorry.
Am I back?
Yes.
Oh, I see that the camera thing is up. Do you guys see that too? Is that still time?
We're just putting you on full screen.
Okay.
You
just did it.
Okay. Let me get it out. Okay, so I was talking about Simon Clark. I wanted to know what it was like to study physics. I came across an Oxford boy who talked about what it was like to study physics at Oxford, and his videos were super insightful because physics is more or less universal, right? It's not like the people who go to Oxford get access to the secret laws of physics, and the rest of us are stuck with just Newton's laws for the rest of our lives. I mean, sure, maybe they're introduced to spherical harmonics, or I don't know, but you get what I'm saying. The physics itself is universal. It shouldn't depend on where you go. But I couldn't help but wonder if the experience that you had depended on if you went to some prestigious university like MIT or Harvard, or if you went to a normal 4-year university like myself. And I couldn't really find the answer to that question, and in a sense, I still don't really have the answer to that question. All I have is my own experiences, and I'm not someone who could have gotten into one of those schools. I couldn't have gotten into MIT. But I still did get to go to a nice four-year university with approachable and helpful professors, a society of physics students that made everything much less daunting. And I thought that maybe some people need to see that. Maybe there's a market for people who just want to see an example of what studying physics is like. So I figured I could do that. So I started making videos and posting them to YouTube. I would record going to and coming from classes, having meetings with SPS, fooling off in like the SPS lounge where we just watch like Rick and Morty or something like that. The videos were super cringy. They really were. They still are. I mean, let's be honest. But they were honest. And so that was the first thing, was I just started doing these vlogs. And I enjoyed talking about what I was actually learning because there wasn't much on that. There weren't many people who were talking about Clebsch-Gordon coefficients or something. I don't know why I'm picking on Clebsch-Gordon coefficients. I just go with it. But if I started talking about things like that, I wanted to be able to explain what it was rather than just throw all these buzzwords at people and have it go over their head, maybe scare them away. But I wasn't able to go in too much depth in the vlogs for a couple reasons. One was because I didn't understand it well enough to do that in the first place. And the second reason was because a vlog isn't the place to have a 10-minute aside on what the space of direct products of states means. Like that's just not the time and place. So that's when I started exploring a different video format for physics communication, which is the more common one, video lectures. We're all familiar with Khan Academy, right? I mean, it's inarguably probably the best resource for learning introductory level physics. The thing is if Khan Academy went away tomorrow, there's still a million other people solving the inclined plane problem on YouTube, right? There's no shortage of that kind of education. So what this was it was my first kind of opportunity to do something new and branch out a little bit, not just copy what everyone else was doing. And it was something that I really enjoyed. So for example, instead of just solving the kinematic equations for some projectile in motion, I would derive them, or I'd show how to convert Maxwell's equations between differential and integral forms. Super basic stuff, but it was what I was learning at the time, and as they got further in physics, that stuff scaled up accordingly. So now it's stuff, I don't know, deriving things in tensor calculus, which is always fun. I guess that's relative to who you are. Some of you might not do that on your Friday nights, but to each their own. Take another step. Any questions so far? No questions or comments? Okay. So that's two things that I started doing, the vlogs and the heavier derivation videos, or the heavier physics videos. And at the time, my mom and my best friend were my only two subscribers. And this was kind of for a good reason. I didn't advertise to my friends and family that I made physics videos because I wanted to be sure that the people who did subscribe found me because they wanted to know what physics was like, and they weren't just being a supportive friend. I don't know how familiar you are with the algorithm, if that's what you want to call it, but it's kind of hard to find videos with very few views. So you gotta dig. You had to dig to find my channel. So when I saw the subscriber count go from 2 to 3, I knew that meant that I was in business. It got to the point where I wanted to show a bit of the lighter side of physics. It was a bit one-sided. It was like, here's all this stuff that I'm learning and abstract vector spaces, and here's how to derive stuff, but it's not all serious. So that's when I decided to make kind of a You Have You Lose physics edition video with some friends from SPS. We wrote a bunch of original kind of physics one-liners, and we just tried to make people laugh. That was my first attempt at doing physics comedy. And it went surprisingly well. Some of them ended up, I found out afterwards, they didn't write all of their jokes. They've been punished accordingly. For example, one of them didn't all of their jokes, Kelly. So what I did was I started a relationship with her, and we moved across the country and moved in together and are going to grad school together. And that's kind of the life story. Yeah, that's the natural thing to do. But the joke videos were where the channel started to gain some sense of traction. There's a market for physics-based comedy. Who knew? For spring break, I took a look back at how many videos I had made over the first year, and it was something pathetic like 26 videos over an entire year. And my stupid excuse for not making more was I needed time to make sure that it was perfect and it came out the way. These videos were terrible. I didn't have the skill set to make a good video, so there was no reason to postpone making them. So the only way I saw to develop the skill set was to start making as many as possible. It was an idea that I adopted from Casey Neistat's videos. I don't know if you guys are familiar with him, he makes a lot of vlogs, and he was a movie maker guy, and he noticed that he wasn't making as many as he wanted for the same reason, so he gave himself a challenge to make a new vlog every single day. And I said, I like that idea. That sounds like a lot. I don't know how long I can keep that going, but I like that idea. And that's what I started to do. I made a new video every single day for as long as I could. And in the process of doing this, I started to learn what videos were for me, which ones I liked doing, which ones weren't really my style, and I started to learn how to edit better and faster, how to tell a better story. And someone once said that if you start making videos, your first 50 or so are gonna be bad. That's your learning phase. You're learning what works, what doesn't. You're just figuring stuff out. And it's good that it's your first 50 videos because that's when no one's watching to begin with, so you can make all the mistakes you want. The view count still stuck at 2 for my mom and my best friend, but that's when I was figuring things out. And what started out partially as a means of determining what videos I enjoyed making eventually became my thing. I was searching for what my thing would be, but it turned out my thing was making daily videos. The longer I made these videos, the harder it was to stop because it started to gain momentum. It was easier to keep making them because I've been making them for so long. It's easier to steer to something that's already moving. And aside from the days that I had to drive across the country to move for grad school, I can pretty much count on one hand how many times I missed a daily upload. And it came out to me making about 314 daily uploads every single day. I would find something to talk about with physics, which was cool. It gave me an excuse to do something every day worth recording. Not all of them were created equally. Some of them were pretty boring videos, but still. And that carried me all the way into grad school. And so I'm kind of rambling on right now. Are there any questions or comments about that process? There's like 314 daily videos, anything like that?
Yeah. Have you ever presented information that you later realized to be incorrect?
Yes. Yes, I did. And luckily it happened when a lot of people started watching. I've only removed a video one time because I said the wrong thing too many times. If I say something wrong once and it doesn't really affect the video, I'll put a comment in the video in the editing process that says, hey, I'm being stupid right here. I meant to put X prime or whatever, you get the idea. There was one video that I made finding the eigenvalue of a Mobius strip. There's that one scene in Avengers Endgame where Tony Stark is talking to Friday, and he says, give me a Mobius strip inverted, what's its eigenvalue? And I made a whole video dissecting that statement where I said, if we had to make sense of this, how could we do it? So I combined a little quantum particle to a Mobius strip, and I solved the Schrödinger equation. And the whole video, I'm saying, the hardest part of this is finding the right boundary conditions to impose. What the heck are Mobius strip boundary conditions? And I ended up using the wrong ones. And it was like a 40-minute video. And someone pointed out, and I had to really think if they were right or not. I found out that they were right, that I imposed the wrong conditions. I removed the video and re-recorded it with the right ones, and then fixed my mistake. But yeah, so I have said the wrong thing before, but yeah, that was embarrassing. That was some time. Cool. Speaking of grad school, I didn't get into mine right away. I was rejected, and I decided to take a very big risk and move across the country to Mexico, where I'm at right now, to pay to take classes at the school that rejected me, so I could take their classes in their balls in their court and prove to them that I had what it took. And classes cost money, rent is a thing. So I put out a post to my community tab or something, to my, I think, 8,000 subscribers at the time, and I was saying that I was offering an online Skype tutoring service. And just enough people signed up to where my first semester of grad school, I was able to pay for rent and everything like that. I was able to barely scrape by. So the audience that came from me making these daily uploads was the reason I was able to keep pursuing my PhD when things weren't going so well. And that's something that I'll always remember and appreciate. But the next semester, I did get into the university for the PhD program, so that was good. That was much less stressful. It made it so that I didn't move across the country for no reason. And now I had a TA responsibility. Now I was officially part of the graduate program. I had TA duties, and it started to become more apparent that the daily upload thing was going to have to become a thing of the past. There just weren't enough hours in the day, and that terrified the hell out of me. Because I started 2 subscribers, I started doing daily uploads, and to me, going up to 8,000, that was huge. So I knew what happened if I kept doing those. I'd keep gaining that traction bit by bit. But if I stopped, I didn't know if everyone left with that. So it was really scary. And but I had the trust that it was the right thing to do. I called it quits on the daily uploads, and it took me 2 years of making videos to gain 10,000 subscribers. The year that I stopped making daily uploads, and I really put to test if I learned how to edit, tell a story, make higher quality videos with the extra time, it went from 10,000 to, as Miles said, I guess close to 130,000, which is where I'm at now. So things worked out, thankfully. But going back to when I graduated from undergrad, I started to narrow it down thanks to these daily uploads, the 3 kinds of videos that I like to make, the vlogs, the comedic videos, and the heavier derivation videos. I'm pointing at the board because I was working on one earlier. And since I graduated undergrad, these videos all scaled with it. Instead of the vlogs being about what it's like to do undergraduate physics, it was about what it's like to do grad physics, what it's like to learn to become a professional researcher. The comedic videos became skits, where I'd start to collaborate with other content creators on YouTube, and the heavier derivation videos just kept getting more unnecessarily complicated. And at first glance, these are wildly different formats. But in a way, they all achieve the same thing. What they do is they show students what's next in their own way. Some people, when they come home, they don't want to watch a video on tensor calculus. They want to watch a story unfold. So they watch the vlog, and it lets them see in some way what might be in their future. Or they just want to laugh at the end of the day, and they watch a meme review. And I'll get comments that are saying, I didn't get what any of these jokes meant, but I can't wait until I do. And the same thing goes for the heavier math videos. There are high schoolers watching the series on tensor calculus that they're not short videos. They're not quick and to the point. No, these are 30-minute videos. The high schoolers watch them, the whole thing. They say, they didn't understand what I was writing down, but one day they'll understand what those symbols meant. And I get those comments on a daily basis. So this idea that you have to present only the surface level, the most extreme, meaty theories out there to catch people's attention, I don't think is true. People want to know what's real more than they want to know what's entertaining, I think. So that's worth exploring more to me. But I'm in grad school now. I can no longer share new undergraduate experiences of mine, but all of you guys are undergrads, all of you all are undergrads, so it's kind of up to you now. You can do that. And when I'm nearing the end of my PhD, I'll be looking to YouTube to see what doing a postdoc is like, what being a professor is like. We all learn the same physics, but the experience is unique to the individual. And I said that I wonder if the experience depends on what school you went to. I'm sure it does, but I think we all know that it depends on more than that, right? I went through my academic career with certain opportunities and privileges that other people just didn't have. So it's incredibly important that they get to share their perspectives as well. If you only listen to what I have to say, it gives you a very skewed idea of what studying physics is like. It's not representing everybody. So this is a new avenue of reaching future generations who are interested in whatever the hell it is that you're doing. And I encourage you all to be a part of that. So as you go farther and farther, my stuff is becoming more niche. Not everyone's going to go into theoretical nuclear physics. Some people go to solid state, condensed matter, cosmology. There's a market for people saying, okay, this is what a day in the life of someone doing that is like. So, that's the gist of what this talk is I'd like to convert as many of you to tell your story and share your perspectives as possible. So thank you for hearing the talk.
So now we usually leave time for people to ask questions. So what I'm going to ask is for people who do have questions to line up on the aisles and to just approach the microphone one by one. So it'll be easiest for him to understand your questions and you know what I'm saying.
How did you start collaborating with other YouTubers? What was the experience of just reaching out to other YouTubers who might be perceived as popular and stuff? And how did you come to contact with them?
That's a good question. I never did. There's that you all might be familiar with. It's a channel called Flammable Maths. Yeah. So the person who runs that, Jens, he's a good buddy of mine. He was the first person to reach out to me. At the time, I think I had, let's call it 10,000 subscribers. He had something closer to 50 or 60,000. Maybe it was, I don't know. He had more than I did, and he reached out to me to include me in his Math Ventures video. It's some Christmas video, I think. And that's what kind of put me, I guess, on the radar for other people to reach out. The reason I don't reach out too often to other content creators is because I barely have time to make my videos, and for the other people that make them, that's kind of what their thing is. Their thing is they're much better than me at making their videos and communicating the message that they want to get by, because in part that's their goal. Their goal is to be professional science communicators. I think I've made it clear throughout my videos, my goal at the end of the day is to be a researcher. So I put more time and energy into that, into moving that needle forward than furthering my career in YouTube, if that's even, that sounded weird to even say. So what that does is it makes it, it made it so that I don't reach out as much as I should to the people who are also in the community. We're all friends, which is cool. We're in the same group chat where we talk, but I've never gotten around to actually make the videos that I've wanted to make with other people. So, a long answer to your question.
So you said you want to be a researcher, but have you ever considered other things, even during your physics career? Has there ever been a moment where you thought that you might not actually want to do physics after you started doing physics?
There was one instance that made me kind of have a uh-oh moment in doing physics, and that's when I was doing my first internship, and I learned how competitive getting a full-time job is in academia. So especially, I don't know, I can only speak, I guess, for theoretical nuclear physics. One of my research advisors at Jefferson Lab said, being a nuclear theorist is a lot like being a musician. If you are the best musician, you're going to be fine. You're going to have a record label. Your life's set. If you're a very good musician, it's going to be hard for you. You're going to be doing all of these gigs where you don't want to go. And he was saying you kind of have to be the best of the best to do that. And I had to really reflect on that a bit to see, is that the road, is that worth it? That it's kind of uncertain. You spend 4 years in undergrad, 4 years at grad school, get a PhD, do postdocs, and you still have to spend another bunch of years to get a full-time faculty position somewhere. Is that worth it? So it's not necessarily that I was second guessing it, it was that I had to think more about it because I hadn't really considered that. But since I started physics, I've always wanted to be a researcher, and that hasn't changed.
So, does your YouTube channel have sponsors? And if so, how did you get those sponsors?
What does your shirt say? Hold on, let me see your shirt. Is that
It's
Maxwell?
actually God said, and it's the Maxwell's equation, just from the MIT museum.
Oh, okay, that's cool. Sponsors. So I started getting certain sponsor offers probably around like 10,000 subscribers. And it wasn't like from things that you would recognize. It would be weird, like PDF converter apps. I was like, I don't want to use that. I use LaTeX like a normal person, and that sends it directly to a PDF. So I started getting offers from those. I've never, actually no, that's not true. I have reached out a couple times to try to set up potential sponsorships, and they never worked out. So all of the ones that I have done have been from them approaching me. For example, I've done a sponsored video for Dollar Shave Club, which was interesting because I don't shave. I have done a couple with Great Courses Plus, and I think those are the only two that I've done. However, my inbox was filled with like weird sponsorship offers. Raid Shadow Legends. I was like, but yeah, that's how that goes. I don't really search for them too much. They're stressful, man. Then they have to do well. Then the video has to do well. But things like Great Courses was cool because they give you this expected view count. Like they say, here's the going rate, assuming you get this many views on this sponsored video. And I was like, well, what happens if it doesn't get that many videos? And they said, well, then we take you to court. No, they didn't say that. They said that we just expect maybe like another video where you shout us out that kind of offsets that discrepancy. So that was pretty cool to know. Okay.
So I want to ask, one, what's the most satisfying physics course that you've ever taken? And then two, what's in the other mug?
This one? This one?
Yeah.
Or this isn't a, or this one?
Black mug.
This is actually coffee. I debated. I was like, man, as soon as this is done, I'm going to pour myself a little glass of whiskey, wind down for the night. But no, I'm not drinking and driving tonight. Oh, didn't you ask another question? Oh, most satisfying class.
Yeah.
Man, that's a tough question. The most satisfying class was probably, okay, last semester was the most brutal semester of my life, hands down. I've never been so consistently stressed and like feeling overworked, but it was the semester that I've gotten the most out of. I've learned so much from the courses last semester. Namely, two courses in particular, high energy physics, which is like our course in particle physics, and our experimental nuclear physics lab. The reason it was so satisfying is because I knew nothing about how experimental stuff worked, and now I feel like I can carry a conversation with an experimentalist, assuming they don't use too much of the, did you hear about the new PM43X model? Oscilloscope, that stuff I can't really follow too much, but overall how accelerators work and how particle physics evolved over time, I got so much out of that. That's probably the most satisfying.
So yeah, I have two questions. Firstly, what's the most valuable skill you learned about communicating science to other people from making your videos? And secondly, what's your favorite science communication channel other than yours?
Let's see. So, could you repeat the first question? I'm sorry.
What's the most valuable skill you learned from making your videos in terms of communication?
Okay. The most valuable skill, someone had the same question that I had. There are often times where I go through a derivation or something in a video, and I could go so in depth with the process, with the research, because especially at this point, I don't want to be putting wrong stuff online. The internet's not too forgiving. So I make sure any question that I have or any step is pretty thorough. And there was a time where I wasn't sure if that was necessary. Like, if people were like, get to the point, you don't need to go through all of this, it makes it really hard to watch. So the first thing is there's no such thing as being too thorough. I don't think you can always skip a video or skip through a video, but you can't get an explanation that's not there. That's one thing. The second thing was something that my dad's told me before, back when I was tutoring a lot. When it comes to helping other people, if someone asks for your help, they get that you're smart. Okay, there's no need to prove to them that you know a lot of stuff, by using a bunch of complicated equations. They get that already. They're looking for help. They're looking for something to be explained simply, and that's harder to do than I thought it was. It's very easy to have an abstract understanding of the things that you learn, but learning how to explain things simply is very hard. I don't have it down yet, but that was pointed out that needs to be something emphasized more in the videos. So putting things simply, and whatever I said as my first example, I forgot.
What role do you think that your YouTube channel and like science communication is going to play in your career, in the next couple of years, as well as once you finish your PhD?
I'm going to answer your question. I just realized I didn't answer the other part of the last person's question on my favorite channels or content, whatever, science communicators. To answer the question about the favorite communicators, personally, I always like to watch PBS Space Time. There's the chances that don't have a million subscribers that I always like, with Simon Clark, Flammable Maths, Epic Math Time, Major Prep, formerly known as, he's Zach Starr now, he's reinvented himself. And there's a professor at University of Colorado, the School of Mines, Alex, I don't know how his last name's pronounced, I think it's Flournoy or something like that. He does the best lectures on particle physics and general relativity. So I've been binging those lately. And then I don't know what the last question was.
What role do you want science education to play in your career, in the next couple of years, as well as PhD?
I just like documenting the process, to be honest. I don't have huge goals for being any face of science communication necessarily. I like getting more people involved. I'd like to be able to document the process all the way to becoming an actual physics professor. I guess that's the role that I want. I want to be, the first person to actually go all the way through. Not the first person to become a professor, but the first person to have to document.
So actually, a really similar question to that. I've never thought about giving UChicago and bluegrass ties a run for their money, maybe write a book or something.
Oh man. Writing a book. My sister is the English student. I would have to consult her every step along the way on how to write things. When do you use a semicolon? Don't get me wrong, I would like the opportunity to be part of explaining things or communicating science at a mass scale. For example, I was on TV one time, maybe it's been multiple times, for the show that's called What on Earth? You seen that alien meme, or the alien guy meme? Well, it's aliens. They gave me a bunch of stories where it's GPS satellites of weird things around the Earth, and they ask professionals to speculate on what it is, and they kind of feed you some topics to bring up. I sounded like an idiot on that. I sounded like an alien conspiracy theorist because they brought up a meteor hitting the Earth and life starting from other planets, and that's that whole thing. If I were to ever be in that position, I would want much more control over what like the editing process and what gets said. Yeah, I do have a huge respect for people who can put themselves in the spotlight for the pop science stuff, like Michio Kaku. Not to say that that's what they're doing, but that's just the only kind of related thing that I've been exposed to so far.
So you said you're interested in becoming a professor and kind of the research aspect. Are you
Sure.
as well interested in kind of like developing like undergrad teaching sort of style, or is it more of just like the pure academia sort of thing?
I like teaching. I don't see myself enjoying teaching like intro physics necessarily. My research advisor was out of town for a week or so I had to give his lectures in modern physics in his absence. So that's when the students were learning, they're getting their first exposure to special relativity. So I got to teach them about relativistic energy and momentum. I made them suffer through learning about four vectors, which maybe wasn't the best idea for their first exposure, but I really did enjoy that. So teaching undergrads, yeah, for sure. I would like a package deal to answer the question. I would like to do research and teach.
Like, how much time it takes for to make a video? Like, since say your first video to now, what's the transition that you had time to make a video?
Oh, it varies. So it depends on the type of video. Let's narrow it down to the three kinds: the vlogs, what do I do? The derivation videos, and the comedic ones. The comedic ones, I can write all of the jokes in like an hour or so, but acting it out and doing the multiple things to make sure the delivery works, whatever that means, that can take a few hours. So I think the latest, I don't remember what it was. Oh, the TA video that I did recently. That one took probably 7 hours start to finish to make all the way. A derivation video probably does about the same thing because I comb through the information so much. The vlogs take probably the longest because they span a longer time, and there has to be transitions, there has to be B-roll, you have to make sure that you, the editing just takes longer as well. So, but I guess all in all, maybe around five or so hours on average.
How did
But
you
those
decide between
are
how did you decide your field and repeat alien experiment and specifically nuclear physics?
For me, I've always known that it's theory or nothing. I've never had an interest in going the experimental route, just because I've enjoyed the math more, and I've never been particularly good with my hands, so that lent itself to theory more. So for me, theory was never an option. I always wanted to do theoretical physics. Nuclear physics, I guess it's a matter of opportunity. So my first research experience, my REU at Jefferson Lab, was in accelerator physics. It was fun. I knew that it wasn't for me after doing it. I wanted something, the math was okay. I guess that was what sold me for nuclear physics. I like the math more. I like working with tensors, Lorentz invariants, the group theory, it's fun. There was a time where I thought I'd like to do something in GR, because it's a similar branch of math. I just didn't know what the hell I would do with that. But, so the second research internship, I got it through one of my old professors of computational physics, and he does research in what's called perturbative quantum chromodynamics, perturbative QCD. QCD, the quantum field theory of the strong interaction. So that was the first exposure, and I was like, okay, cool, I can get behind this.
Do the student PTA or your professors know about your channel? Is that weird?
Yeah, they do now, and it's weird. It was my dirty little secret for so long, and then I'm very awkward when someone brings it up. Someone's like, if I meet someone new and a friend says that I make, I just cringe. It's so uncomfortable. But yeah, my professors found out that I make YouTube videos after seeing my video where I make fun of professors. Like the one one video where I'm not making fun of myself. Yeah, that's the one that everyone saw. Okay.
Yeah, what are a couple of particularly memorable breakthrough moments you've had in your research? Number one, and number two, dog or cat person.
Really?
Okay. Just so I feel like I'm making my way through the question, I'll answer the second one first. I am a dog person.
Yeah.
I always, dude, it's weird. Okay. I have never liked cats. Kelly has a cat named Meow Meow. And it's all right, let me tell a little bit of a story. I'll be really quick. When we first moved here, the cat came too. I guess it had to. And I was allergic to cats in Virginia. So if I set up a boundary in this room, cat can't come in, so I don't have to worry about sneezing. The cat would sit in the threshold of the door, and it was like trying me every single day. Every day it would come a little bit closer. I got a squirt bottle. I was like, I will do it, okay? Don't make me, you're cute. And she got to the point where she would jump up on my desk, and then she'd see the squirt bottle, she'd start rubbing her face against the squirt bottle. Like, dude, you're hardcore. Okay, you can stay. So I don't like cats. I like this cat though. Most memorable breakthrough or something in my research. I have to be honest. I'm not. My first semester and a half of grad school, I didn't do much research because I wasn't a real grad student yet. So my only frame of reference in grad school research has to do with the two projects that I'm working on currently. One I mentioned earlier, calculating matrix elements of the energy momentum tensor. And this physics experiment, you measure cross sections, right? It gives you probability of something happening, of a certain process happening. I really can't say there's been any memorable breakthroughs for either of them so far, just because they're still so new. And as far as the undergraduate research experiences go, the first time I got a code to work was pretty great. It was for my accelerator physics project. My advisor was like, yeah, everything, we need to write a code that has a multi-objective thing that you have to optimize. Do you know Python? It's like, no. He's like, you're going to learn Python. And when it finally started to, so I think compiling the code for the first time is at least memorable. And then, but let's see. Yeah, it always comes down to coding with what I do. So much of what I do isn't necessarily pen and paper. It probably could be analytic, but you don't want to write out these expressions. You let Mathematica take care of it for you. So finally understanding the theory enough at each step of the way to where I know what the hell I'm compiling in the first place is always very cathartic for me. It's like, cool, I do understand what I'm doing. Yeah.
This is the microphone.
You're sending a little too close.
Okay, so have you ever considered maybe like expanding into teaching or expanding the channel and focusing on things on people younger than undergrads? So like, have you ever considered expanding the channel down to like maybe consider teaching or expanding the channel down to middle schoolers or high schoolers?
So it has come into my mind. The way that I look at it is, and maybe I'm not right. It's just my the way that I think about it is there are so many other resources for, say, middle school, high school, undergraduate physics that you can go to. There's so many different ways that people are explaining the same thing. Any problem in algebra, any problem in, basic classical mechanics, it's been asked a million times in a million different ways, so the solutions are there. I don't really know what my role would be in that, because there's so many resources already. So maybe it's my own desire to need to be relevant that pushes me to go to the more upper level topics, because there's less of a market for it, but there's also less competition. So maybe that's why I naturally gravitate to it, because it feels like I found my place there. But yeah, as it stands, I'm not sure what I could offer to those levels that hasn't really been done.
Andrew, I was just wondering if you could talk about what the energy momentum tensor is. And I hear nervous chuckles, but I don't know.
Sure. Yeah, so, 1 second. My camera's here, isn't it? Okay. You guys can see this? So, the left-hand, if you take, my research isn't in gravity, by the way, but it's what's more familiar to people. If you consider the left-hand side of Einstein's field equations, we have, here we go, pressure's on. The curvature, or the Ricci tensor minus 1/2 r g mu nu plus cosmological constant g mu nu is equal to, what is it, 8 pi g over c to the 4th. I'm doing covariance of a t mu nu. Einstein's theory of general relativity relates these two sides of the equations. On the right side of the equation, that is the energy momentum tensor. So what it tells us is that the geometry of the space-time is influenced not just by mass, but it's influenced by anything that contributes to the total energy, which can be the momentum, the energy density, some kind of momentum flux or energy flux, pressure. All of these things contribute to the energy. And all of this tells, as it turns out, affects how the space-time is warped, or the geometry of the space-time. So you understand the relation, or the saying, what does it matter tells space-time how to curve space-time tells matter how to move. So we get a lot of hints, let me get back in the frame, we get a lot of hints of what the energy momentum tensor should look like and the behavior it should have from general relativity. What I do is I work with the energy momentum tensor in the context of quantum field theory, and it's defined in a different way. You see, in an abstract way, the energy momentum tensor in general relativity is proportional to some derivative of the action with respect to the metric. What that means, don't worry about it. Just know that that's not how we typically define it in field theory. In field theory, it's defined by conservation laws. So to get the energy momentum tensor in field theory, you exploit what's called Noether's theorem, which says that for every continuous global symmetry, something is conserved. If you have a symmetry over spatial translations, momentum is conserved. If it doesn't matter where you do your experiment, momentum is conserved. If it doesn't matter when you do your experiment, if it's a symmetry under time translations, energy is conserved. If both are satisfied, energy momentum tensor is conserved. How it's defined in quantum field theory, in terms of Noether's theorem, is purely academic. No one really uses the Noether's theorem definition of the energy momentum tensor in field theory because general relativity tells us that it should be a symmetric tensor. Noether's theorem doesn't require that. So what I do is I work with a modified version of it that is symmetric, and I calculate what this guy is for different interactions. Because when you expand this guy out, you get terms that have to do with the energy of the particles, the mass, the spin, which can contribute to the energy, the angular momentum. And there's an additional term called the D term that we don't know what it means. There's speculation that it corresponds to some kind of internal pressure of the nucleon, so understanding this D term can tell you if in developing a model that you create to solve field theory problems, does it actually correspond to a stable particle or not? So that's what I'm investigating. Sorry if that was way a lot.
I think that's all the questions that everyone has. Thank you so much for taking the time to give a talk for us. And let's thank Andrew Dotson one more time.
Very fun to do. I've only gotten the chance to talk about this stuff one other time, so it feels good that people care to have me talk about this stuff. It's very it's pretty surreal. So thank you for your time. I hope you guys get home safe and enjoy the rest of your Monday.
Thank you.